So this is chapter 12, pediatric dosages, so now children. This is actually a very, very quick section, or a quick chapter, and it's pretty much a summary of everything we've done so far. The main thing about pediatrics is obviously the weight of the patient, so weights of children becomes a huge part when it comes to these type of sections itself. But so in other words, we're going to go back to mostly BSA when it comes to these type of questions. So you may want to brush up on those equations as well. Okay, so let's actually do this out. Okay. So pediatric dosages. So these drugs are based on the weight of the patient, or again, BSA, right, when it comes to it. So also, when it comes to the pediatrics, you must always determine if the amount of the dosage is in the recommended range by looking at the reviewable drugs or resources. So package information, so hospital, and all that information will be given to you. So it's not like you have to memorize it. Just, just make sure it's pretty much labeled, right, when it comes to it. So to reduce error in medication, the medication is in units dosage. So, but the nurse is still responsible for verifying the accuracy, right? So obviously, right, you always have, last say when it comes to giving the patient, since you're the one give it to it, right? So make sure you always understand and always check the dosage itself, right? Make sure it's 1-to-1. So obviously the key thing, like I said earlier, dosage is always the weight of the patient is the most important when it comes to pediatrics. So again, like I said, this is pretty much a summary of everything, which is good. Nothing really new when it comes to, we're just going to add, keep going when it comes down reintroducing BSA, as you'll see right now. Okay, so let's just go through the example so you can see how that works. So example one says, Virex oral 15 milligrams. So again, a little bit more practice on this kind of stuff, right? Per day divided into 2 equal dosages. That's going to come up in a little bit. Okay? If the strength of the Bix is 135 milligrams per milliliter, calculate how many milliliters of this antibiotic a child who weighs 40 kilograms will receive. Okay, so we know, starting off, right, this child weighs 40 kilograms, so that's what's given to us. Okay, and we can do that with the order to cancel out the kilograms, right? So kilograms per day is at the bottom, and this is 15 milligrams on top. So these cancel. However, how do we want milliliters, but the good thing is now we have the strength of the drug, right? Strength is milligrams over milliliters. So we know there's 135 milligrams for every 5 milliliters of this drug, and that's how we get milliliters. So multiplying out, we get 22.2 milliliters per day. Now remember, it's still per day because the day did not cancel. Okay, so we still actually use that in our individual cases itself. Okay, now here's a fun fact. When it says divided into 2 equal segments, okay, well, this is just the total. So if I ask you a follow-up question, how much would each dose would actually be, you would divide it by 2, since it's in the whole day itself. So you would get about 11.1 milliliters each dosage. Does that make sense? Because again, it said 2 equal doses. So that would be a part 2 question if you guys are wondering how that would come into play. So following this kind of stuff, like last section, right? Dividing into doses by the pushback and stuff. All right, so let's keep going. So example 2 says 19 milligrams per kilogram PO oral for a child who weighs 35 grams. If the strength of the drug is 300 milligrams for 5 milliliters, calculate the number of milliliters of this antibiotic the child will receive. So we want milliliters. So, well, what's given to us? Well, the only thing is the weight of the patient. So this child weighs 35 kilograms. How to get rid of kilograms? The order. Okay. But again, right, we don't want milligrams. We want milliliters. So now we use the actual strength of it. And you should get 11.1 milliliters. And there we go. All right, so let's keep going. So actually, why don't you guys try 3 and 4 real quick? A little bit of practice. So quick pause, 3, 2, 1, pause. Okay, so hopefully you guys try them. So if the recommended dosage for a drug is 8.5 milligrams per kilogram every 8 hours, and an infant weighs 2,300 grams, how many milligrams of this drug would be administered to the infant in 1 day? Okay, so we want milligrams. So the only thing we know is the weight of the patient, right? The weight of this child. Well, everything's in milligrams, so we want to first convert this. Or we want a patient, so, right? Oh, actually, I could just do it separately. And now from here, we multiply using the order, right? So for every 1 kilogram, there's 8.5 milligrams. So multiplying this out, you should get about 19.55 milligrams. Now, here's the problem. It says in 1 day, correct? But this is per 8 hours. So this is just 1 dose for 8 hours. So that means we have to multiply this by 3, right? Because A goes into 24 3 times. So our final answer is multiplying this by 3 is about 58.68 milligrams because we want it in 1 day, respectively. Okay. Okay, so now let's go to question 4, right? So question 4 says 15 milligrams for m meter squared. Oh, this is BSA, right? M squared. The strength of the tablets is 5 milligrams. Calculate the number of tablets that contains the dosage for a child who weighs, who is 90 centimeters tall and weighs 16 kilograms. So, back portion, right? Remember how to find BSA. So since we're given centimeters and kilograms, it's going to be 90 times 16 divided by the 360, right? 3600, not the 3131. So first thing we have to find is BSA. So this gives you about 0.632 m squared. Right? And that's actually given to us because that's, how much the child weighs. So starting here, now we go through our process. Well, how do we get rid of m squared? We use our order. Ooh, very sorry. All the way around. Okay, so these cancel. All right, now this is milligrams, and we wanted what? The number of tablets, right? We wanted how many tablets there are. Well, it says each tablet has a strength of 5 milligrams, so we know for every 5 milligrams, there's 1 tablet. So multiplying these all out and dividing, she gives you about 1.8 tablets. Well, let's say approximately 2 to be per more, out there when it comes to it. So like I said, right, it's kind of still the same thing. Nothing too bad when it comes to it. Okay. All right, so now let's go to the last couple examples of this chapter. Pretty quick chapter. Okay. So last things to say is example 5 is given, or the order says 60 milligrams IM. So little review, right? IM 8 hours for a child that weighs 74 pounds. If the strength of the vial is 85 milligrams per 5 milliliters, determine the number of milliliters you would administer. Okay, so let's see what's happening here. So first, we want to figure out how many milliliters we want, right, when it comes to it. So first, how many milliliters? Well, that's interesting. We have the strength of the vial is in milligrams per milliliter, right? And we also told that the order is 60 milligrams, right? Well, that's interesting. So we want that. Notice we're actually not even going to use the weight of the patient at all this time. So the weight of the patient was given to you just by extra portion. You actually don't even need it because these cancel and we just get our answer of roughly 3.53 milliliters. So you still got to be very aware, just because they give you the weight of something or they give you this doesn't always mean you're actually going to be using it, okay? So just be very careful and make sure you know how stuff is used as well, okay? So it can be a trick question, just giving extra information you actually don't need, okay? Oh. Right, last example of chapter 12. So the order states for a child 3.5 milligrams IVP, so push, right? The package states that the recommended dosage is 0.15 to 4.5 milligrams per kilogram per day IV push. The child weighs 35 pounds, and the label on the vial says 10 milligrams per milliliter. Okay. question is the ordered dose within the range that is recommended? This is an interesting question, right? So what we want to do is convert the ranges into the dosage itself, right? So in our case, it is 3.5, right? That's our order, 3.5. So we want to convert that to how many milligrams per day this is actually going to be, okay? So we want to convert each one, so it's going to be 0.15 milligrams per kilogram per day. And our goal is to convert this into just milligrams per day. So what we can do is going to multiply by the weight of the patient, which is 35 pounds. Well, first thing I got to do is convert that into kilograms, right? So there's 2.2 pounds for every 1 kilogram. So multiplying this out, or actually dividing this out, gives you about 15.9 kilograms. Okay. So times 15.9 kilograms, those cancel. So this becomes approximately 2.39 milligrams per day. And then we do the exact same thing for the other doses at 4.5. So 4.5 milligrams per kilogram per day times the same weight. And this should give you 71.59 milligrams per day. So is our order within the range? Yes, right? It's between these two numbers, so this is a yes. It's within the range. Now you could have done the also the other way. So just divided this by the weight of the patient. So if you divide 3.5 divided by 15.9, you would have found out it's also within there. Okay, so it's two different ways you want to do this question if you like. Okay. And then lastly, part B, how many milliliters would you administer? Well, since the order is 3.5 milligrams, sorry, and we know the strength of the vial says there's 10 for every 1. This gives you about 0.35 milliliters. There we go. And that's it for this chapter. Very, very short chapter itself.